that your parents buy you is not going to be a Maserati, right? At least maybe around here. but you know what I mean? Like, you know, it's going to be like I don't know. I don't even know what popular kids' cars are these days. You know, my day it was like a Chevy or something like that. Camaro or something. And so that would be like a really cool but cheap car. Redis is definitely cheap and cool and all that, but it's really for those things that need to be really, really fast. And it dominates in that category. Okay, so, and just real quick, Redis is free and open source, always has been, always will be. You go to redis.io, you can download it there. It's so simple. If all you need is one instance of Redis, you really should never pay for it, unless you want somebody to host it for you and you pay for that. But it's just really simple, really easy, and it kicks butt. Redis Labs primarily exists for companies who are running many Redises. Because once you get to a large implementation, you have lots of Redises. You need to coordinate them. Perhaps you need to shard your key space across many Redis instances, or maybe you need high availability and you have a lot of throughput. So there's a lot going on, and you want to make sure everything's working. Well, we've done this so much now that we've got the best practices all built into our Redis Enterprise product. And you can get access to that Redis Enterprise product really in 3 different ways. You can go to redislabs.com and click Try Now and get a free account. You can use it for up to 30 megabytes for free forever, where you can use it. It's not like a trial thing. It says trial, but it's not trial. It's permanent, up to 30 megabytes. After that, you start paying based on the amount of megabytes or gigs that you use. You can also use Redis Cloud Pro, which is that we're hosting it for you, but it's your own Redis managed in your VPC or your VNet. So it's not, you're not sharing a multi-tenancy database. It's all yours. Okay, so that's, and then we have the software too that you can run yourself, and we sell that. Now, Redis is crazy popular. For those of you who didn't raise your hand, almost every single social web app out there that you can use is using Redis, and now more and more big enterprise-y companies are starting to use Redis as well. So it's really expanding because a lot of these systems need speed, and they have hundreds of thousands or even millions of users. So Redis is pretty much all across the board. The biggest use cases is the cache, like I mentioned before. Another very popular use case is for user session management. When a person logs in, you've got their cookie or their ID, and to find out if they're logged in or not, that's a key value lookup. That's not an SQL query. There's no reason to put that in an SQL. It's just going to slow you down. So put that session management in your in Redis, and it'll definitely speed things up. And it's built, oftentimes it's built into a lot of the frameworks. So like Express.js and Django, they all have like Redis built in. So it's usually a configuration option, and you just point it to the Redis, and it'll use Redis for the session management or caching. Why is it different than other databases? Primarily because it's crazy fast. Everything Redis does is for performance. Salvatore, the creator of Redis, he keeps it super tight. There's no overlapping code. Like when a contributor contributes code, he makes sure that there's no duplicate data or code in there. He'll refactor it, make sure that it's reusing all the highest performing bits of Redis. Also, there's lots of different data structures in there. And this is really the cool part about Redis, honestly, is that it's got all these different data structures that are built specifically for different types of performance. So depending on what you're trying to do, you might use a different data structure, and that data structure has commands. It's not like a query language. It has commands that are written as performant as possible for that command. So it is written specifically to do that thing as fast as C programming language can do it, and it's very, very fast. And each one is over about 280 commands at this point, maybe more. And you got a lot of different data structures in there. Almost all of you raise your hand saying use it as a cache. Well, you're probably using the string. It's just a key and a value. It's really simple. The command is set, and then the key name, and then the value. Okay, 3 things, right? Very simple. And then to get it out, you just say get and the key name, and it returns you the value. Crazy simple. You'll learn it in like 5 minutes or less. But then there's all these other data structures, and you need to know what these are, because there's many, many times when these are like the perfect solution for you, you don't know it. So for example, let's move on down to hashes down here. A hash is what we use to store session information, because it's a key, it's the key, and then it's the field value. So you can store a bunch of session information, like all the user name information, maybe the URL to their GIF image, their profile image, their user ID, all that kind of stuff can be simply stored in the same key that you're using to store the session timeout. So as you're checking to see, is the session running, it's coming back with yes, but it's also bringing back all that information that you need every single time, right? So you're killing 2 birds with 1 stone. It also has an automatic timeout. So as you create the key, you can say, I want this to be deleted in 20 minutes. And therefore, when you go to check it in 21 minutes, it's not there, you know that user is no longer logged in. And then, there's all these other data structures that all have very unique use cases. There's a bunch of different use cases here that people use Redis for. Job and queue management, high-speed transactions, messaging, real-time analytics, notifications, fast data ingest, searching, time series data, geospatial indexing, machine learning, graph analysis, all sorts of things. All of this is done in memory. It's all very fast. And you can see that a lot of these in the past have been used to do stream type things, but we didn't have a stream data structure, but we do now. So we have this stream data structure, stream data structure, and all of them have just a key. And so what happens is no matter what data structure you're using, it's just one giant namespace of keys. So when you ask for that key, there's nothing overhead. It just goes straight to the key, and then it grabs the values. Okay, so very, very, very fast. But each one of these data structures is a slightly different data structure. So even though the key lookup is fast, the value lookup depends upon the type of data structure you have. Okay, so for example, if you're using a list data structure, this is literally a list of things. It's a double linked list. So to get to a value in the middle, you can't go straight to it. You have to go from one end to the other. But that's okay, because think about it like it's also kind of like a stream. It's just a list, and you can add things to one side and pop them off the other side. It's excellent for tracking work that needs to get done. One of my favorite ones to talk about is a bitmap. It's just a key with a bunch of 1s and 0s. But what's really cool about that is that you can use it to track things like, let's say you have 200 million users, like Pinterest did a while ago. They had 200 million users, and they wanted to know as quick as possible which one of those were online. Because if you're going to update something like in your one of your pins or whatever, and you want to notify your friends, well, of course Pinterest doesn't want to go through all of your friends and notify them. It wants to notify the ones that are online right now first. So they would keep a 1 or a 0 in one giant key or bitmap. One giant value, which is a bitmap, for each user. And each one of those 1s or 0s was uniquely addressable. So you can pass in a list of your friends. Let's say you have 500 friends. You can pass in the location of each one of those 1s and 0s for each one of your friends, and it would then return only the yeses. So these are the people who are currently online. Okay? And then you can send the message to those folks. And that turned out to be like, I forget, something like 30 gigs of memory for 200 million users. And I mean, you just can't get any more efficient than that. So pretty interesting use cases. There's lots of these kind of use cases. A set, let's say you're, by the way, the original use case for Redis was this list, because Salvatore was trying to store about 100,000 writes per second into a MySQL database, and he just couldn't figure out how to get that to work. MySQL couldn't handle that. But he found out that MySQL could handle 100,000 records at a time. So basically, writing 100 times per second a batch of 1,000 records. It could handle that. And so what he needed to do is queue all this up. So he queued it all up in a list. So 100,000, well, I guess it'd be more like 100 at a time, no, 1,000 at a time, and he batched them into MySQL. MySQL can handle that. So that was how he started. But let's say you want to just ingest only IP addresses. So you want to know all the unique IP addresses coming from around the world to your website. So you can just throw them at a set data structure, and a set data structure is going to only keep unique values. So it's going to automatically just ignore the duplicates. And this is on purpose, because you don't care about the duplicates. And it does the work of figuring that out for you. And then a sorted set is great, because let's say you're Netflix. The true story, Netflix has over 1 billion API calls per second. And what they did is they take all their error messages and they throw them at a Redis sorted set, which is a key, a value, and a score. So the error message would be the value, and then they'd start off with a 1, and the next time that error message came in, they'd increment the 1 to a 2. And so they keep doing that, and so the most popular error messages fly to the top really quick, so you can see where you need to focus your efforts. Geospatial Index, you know, you have Lyft. Okay, Lyft uses, like, they have over 2,000 Redis instances, I think. And that's how they track, among other things, that's how they track the cars on your phone, you know, like the cars moving around. They're using the Geospatial Index, or something like that. But they're using a lot of Redis. Yeah?
So one of these is defined below?
If you want. So, yeah, all of these have different parameters. And no, I don't think all of them have time to live, actually. The hash and the string, the string and the hash definitely do. But the others, it depends on the use case. Some of them don't have a really popular type of use case.
Because over time, whatever your dictionary you keep growing, and you have to have it in memory, right?
Sure.
So you need to take a purge or a evict older stuff or something, whichever is.
Yeah, so Redis has very many different ways in which you can automatically evict keys. So, like for example, you can say,
Least recently used.
yeah, there's least recently used. There's a lot of variations of that where you can just tell Redis to automatically do that for you. So, yeah, there's a lot of built-in capability for Redis. You don't have to write that logic. And, you know, that's why people, every year, for the last 3 years, Redis has been the most loved database on Stack Overflow. Why? Because it does all this work for you. You know, where are you going to write like 20, 30, or 100 lines of code in some other, using some other database? It's just like one function in Redis. So it's awesome. Anyway, there's more examples here. So real quick, what is a cache? You know what a cache is, very easy. You're just going to say, get my key, okay? And then what's going to happen? It comes back and says, oh wait, my key is nil, there's nothing there. Uh-oh, the data is not in Redis. What do I do? Well, you go run an SQL query, or wherever, you know, whatever you need to do to get the data. And you say set my key equal to the results. Let's expire it in 5 seconds. And then next time you just go get my key. And for the next 5 seconds, that data is there. After 5 seconds, it's gone. If you're querying your database, let's say 1,000 times a second, well, you've just scaled your database 5,000 times, right? That's how crazy awesome Redis is. Very simple use case, very, very popular. Okay, so, and by the way, you know, just go to redis.io/commands/set, and there's the information you need on how to use the set command. And it's basically the same thing for all of the, just go to /commands, and you'll see them all. It's a very easy website to follow. The documentation is great. All right, but what I'm here to talk to you about is Redis streams. Okay, so first of all, we should all know what a stream is. And by the way, just for fun, if you download Redis, like on a Mac, it's just brew install Redis. Okay, as long as you got brew, that's it. If you got brew install Redis, you're done. If you're on Ubuntu, apt-get install Redis, you're done. Okay, so it's that easy. Windows is a little tricky. I wrote a blog post about it. Microsoft is getting smart about running Linux-based applications on Windows, but it's still not perfect. We were just trying to follow my blog post, and there's like a new error message because something's changed in Windows, I guess. But Windows has a new thing called the Linux subsystem. Let's see, the Windows subsystem for Linux or something like that, WSL. And what they've done is they've taken and created a whole bunch of libraries that interpret Linux commands and then run them against Windows, but it's your Linux applications will know how to run on those commands. And so if you use WSL, Redis theoretically will run if there's not some, some goofy problem that they've introduced. But and then within the next year, Microsoft is going to actually support Linux, full-blown Linux on Windows. I don't know which version of Linux, but they're going to start with one, like Ubuntu or something, maybe SUSE. And you'll have Linux just on Windows, which is pretty awesome. But here, let me switch over for a second. Just real quick. Here we go. All right, you probably can't see much. All right, so right now you can see well, you can't see it, but I'm going to point this. This HTTP listening on 3000. I'm going to just do a control cancel. All right, and what that did is if you're running Linux Redis, I just basically shut it down. But once you download it, you just simply type in Redis server. Okay, and it's up and running. Oh, something happened. Hold on. Hold on, I'm on the wrong terminal. Wasn't paying attention. Okay, here. Control cancel. Okay, there we go. And then if I type in Redis-server, it's running. Okay, it's on port 6379. 6379 is the default. Okay, now I can go over to another tab here. I'll increase them again. Let me get out of this. So let's start from scratch here. And if I type in Redis-CLI, okay, it's going to put me into a command prompt so I can just type Redis commands. Okay. Now, so I'm in basically the Redis command prompt. Now, if you want to know if you have Redis running, just type in ping, and it responds with pong. Okay, it's like the simplest way to know that yes, it's like hello world, right? Okay, so and then like I said before, if you just want to set a value for like again cache, it's just going to be set, and then it helps. It has a little. By the way, the command line interface installs when you install Redis. Okay, so you don't have to install them separately, but they're two different libraries. So I can say my key, and I can say value. Well, like a real name, a real use case would be like user ID, and then value might be I don't know, Nielsen or something like that. And I can say expire in 5 seconds. Okay, now get user ID. Oops, sorry. Yeah. Sorry. Yeah, it's probably already gone. Yeah, already gone. Okay, so hold on a second. There you go. Oh, I did wrong. Hold on a second. Get user ID. So hold on. I should know my own stuff, right? It's just doing it too fast. There we go. So it came back okay, I guess. So, oh gosh. Yes, we said
more than, yeah.
There you go. Gotta be faster than Redis. So, okay, so that's how it works. It's very simple. And then what you use, of course, in your own programming language, there's a client library for you. There's over 150 different client libraries created by the community. If you just go to redis.io, you'll see them all there. Very easy client libraries to use in your own programming language, okay? All right, so now let's take a more look at Redis, or streams. So, what is a stream? Well, what I'm going to show you right now is a Java app, okay? And what's happening here is if I go to, let's see, yeah, okay, so if I go to stream consumer, no, Twitter ingest stream, okay, and I run this. Okay, what you should see here is what it's doing is it's pulling down messages from Twitter. Okay, and it's actually going through a third-party service because Twitter doesn't really let you do this anymore, but through a third-party service, and it's pulling down, these are all tweets, okay? So now, for example, if I now go and say, let's just stop this for a second. Okay. And if I go over here to next, let's see, keys. You're not really supposed to do this because Redis doesn't like it when you do this. Keys can be a very dangerous command because it literally is going to output all of the keys in Redis, and you might have like millions of keys. Okay, so it's not really the best thing to do. But when you're just doing a demo, it works. I can also just type flush all. That's going to get rid of all of them. And now I do keys, and there's nothing there. Okay, so basically now at this point I have no keys in Redis. So let's go back again. Let's run this. Okay. All right, now let's stop again. Now, if I say keys, how many keys do you think I'm going to get back? How many? I'm going to get, well, in this case, 2. Now, you certainly got a lot more there, right? So what's happening is it's actually creating one key. So a Redis stream has one key, but then it puts all of the entries in that key. So now if I say xlang, so that's xlang, and the key, Twitter stream, it comes back with 70. So in that very short period of time that I had it running, it actually brought down and entered in 70 entries. Okay, so it's storing all of those entries in one key called Twitter stream. All right, is that starting to make sense? Okay, so like, what can you do with this? All right, let me go back over here. Okay, so stream is just, you got a producer. In this case, it's Twitter is creating some data and it's going through a third party and it's producing something. And then what's happening is Redis client library is then sending this into Redis. And it's putting it into a key, and then each one of these is an entry. Okay? So now you got all these entries. Right now we have 70 entries. Okay? And then you got a consumer over here, and your consumer is going to say, hey, I want that data. Give it to me. Okay? And it's going to take them one at a time. Now, at some point you need to scale. You might need to scale on the front end or on the back end. So maybe you don't have that much data. It's like IoT devices, and they're just sending one record every second or something like that. It's not that much. You might have lots of them. They're sending them in here, and they're just coming in and adding up. And maybe you only need one consumer on that side because your consumer can handle, I don't know, 500,000 per second or something like that. So you might only have one, or it might be the other way. You might have just one producer, like in this case, our Twitter stream. And you might try to be doing something a little more fancy. Like, what if inside of each one of those Twitter entries was an image, and you want to process that image and try to figure out what's going on inside of that? Well, that's probably not going to be able to keep up, right? Because there's a lot more going on looking into an image than there is just producing the tweet. So you might need to scale up this side. So the point about streams is that the producers and the consumers are almost never creating data at the same rate. So streams are actually more complicated than just one in and one out. So with Redis, or actually in any situation, you're collecting data, you need to transform it and put it into some format. You're then going to retrieve that data from that format, and then you might do something with it, like analytics or something. Thankfully, Redis already does a lot of this, and now it does it even better with streams. So in the past, you could use PubSub or list or sorted set for this kind of thing to ingest the data. And then if you want to use a message broker or some other, you can use PubSub or lists, etc. To output it, you can use same thing, sorted sets, etc. But now you can just use streams for everything, and it works better. Okay, so here's another example where if I get this whole thing running, so I'm going to go back to running that and then running my collection. Okay. So now I actually have two. Did that crash? That looks like that crashed. Hold on a second. Okay, there we go. Okay, so now I actually have two outputs. So the tweets are going in, and I actually have two outputs. One of them is just the tweets. The other one is, as the data comes in, as each tweet comes in, I look at and figure out that for that follower, how many, for that, for the tweet username, how many followers do they have? And if they have over 10,000 followers, I want to know who they are. So I put them into a different stream, okay? And now what I can do, I go over here, and I can start this sample app, okay? I should be able to see it over here. Okay, so now you can see that this sample app, this is, well, you can't really see this, can you? Hold on a second. Is it because I'm in? Okay, now you can see. So this is a web page that is listening to the web server, and that web server, and it's using PubSub, right? Because I'm not refreshing this page. It's the data is being pushed down to the web page from the server, and the server is a Node.js app which is subscribed to Redis as a consumer. So that Node.js app is just subscribed, listening to the data coming out, actually pulling the data from Redis, and then pushing it down into this web page. And this is a very, very common use case. And this is how Redis actually differentiates from something like Kafka. Because with Kafka, in order to set this up, you're going to need Kafka and you're going to need Redis. Okay? With Redis, you just need Redis. Okay, you can do the PubSub right into the web page. You can do the stream coming into Redis. And in the past, people have used PubSub with Redis. But the difference, and by the way, this is very important, the difference between PubSub and Redis streams is that with PubSub, if you only use PubSub with Redis and not streams, it might actually look exactly like this, but it might also not. Why would it not necessarily look like this? I'll give you a hint. What happens if I close this page? That's a different page I'm going to show now. And I go back. Okay? What do you think is different with streams versus PubSub?
So if the subscriber is not online, it loses those messages, right?
That's right.
That's the way it
That's
is.
right.
Yeah.
PubSub does not care that some messages were created while you were shut down.
Yeah.
It says, that's fine, I don't care about those. So don't give me those, just give me what's new. So PubSub is always saying, give me what's new since I came on. Whereas Stream says, you have an option. With Streams, you can say, yeah, just give me what's new. You can also tell it, no, give me everything from the beginning, or give me everything from this last key, where I last left off. Because in Redis Streams, it's keeping a historical record of the entries that were made. And that's the difference. Redis PubSub does not store anything, whereas Redis Streams does. Okay, and Redis Streams is therefore much more like a Kafka example, right? Okay, yes?
With Redis streams, can you write to any big data lakes or anywhere? Because Kafka, we can get the PubSub and then write anywhere we want.
You absolutely can. However, we don't have as powerful an ecosystem as Kafka has yet. So there's a lot more adapters for Kafka than there are for Redis, but that's coming.
Yeah, maybe that's the differentiating factor why it's still utilizing Kafka.
By no means does Redis ecosystem is built out as Kafka right now. There's no doubt. Okay, but there's a hell of a lot of Redis users out there. So the primary target right now for Redis streams is any use case where you want streams and you want to go down into the client, like this example, or anybody who's already using Redis and they don't want to necessarily install something new. Okay, for example, Redis doesn't require any other software to run. Kafka typically requires Zookeeper, so it's a little bit more cumbersome to set up and manage. Okay, so if you want quick, lightweight Redis, to do all this, you can have all of this. Otherwise you have more work to do. Again, I'm not putting down Kafka, it's great, it's just, there's different use cases where Redis fits in.
Yeah, I agree. Redis is very good for keeping the users and then the different nodes it is going to for a application like Twitter or any of the messaging systems.
Yeah, yeah,
It's very good.
yeah. So, like for example, yes.
Is there a limit on the number of, you said one stream and then another stream, right? Is there a limit on the number?
No, you can have as many streams. You can also have as many, consumer groups. So there's, obviously you're limited by memory, but yeah, you can keep going. Now, when it gets to sharding, I'm not very good in that yet, but you can also shard across multiple servers. I'm just not good at explaining that yet. Okay. Yeah.
It supports channels, like chat servers or something?
Yes, absolutely. You're talking about like consumer groups, like groups, right? Is that what you mean?
Right.
Yeah, we definitely do. In fact, I'll get to that. Let me get to that part. Yeah. Oh, his question is, does it support channels? I think it's the same. Another way of saying groups. Consumer groups. I think it's the same thing as channels. Okay, so let's go back here.
How is it different from Spark Stream?
That's another good question. I'm not sure, actually. Is Chris still here? Chris may have left. So Chris will be able to answer that really well. Spark streaming requires Spark. I don't really know Spark streaming well enough to tell you. I'm just guessing when I say that Redis is probably faster, but I have no real information to base that on. So I don't really know. But let's go a little bit further here. Okay, so again, I told you before that with streams, usually your consumers and your producers are not operating at the same speed, so you might need more. You also might have multiple consumers. In this example right here, we have 3 different applications. They all need the data. So they're not sharing the load, they're each getting every one of these entries, okay? Because in this case, we have some sort of messaging app, but we also want to do analytics on the messages, and we also want to back up things, okay? So that's 3 different places that the data needs to go, okay? But you also might have a catch-up problem where you have a producer that's creating 500 entries per second. You have a consumer of only 100 entries per second. It's just going to fall further and further and further behind. It'll never catch up. That's fast, that's slow, and you end up with a growing stream. So what you might do, like for example, 500 per second, each one of these 100 per second is able to process an image at 100 per second, so you might need 5 of them, and now you've kind of matched up, right? There is a company in the IoT space which is capturing video, and they're actually putting the Redis client library in the camera, and it's actually sending over the public internet through SSH the images. They're small images of 100K, and so it's actually streaming images to the server where it then processes those images, all in Redis. And this is the kind of use case that we're seeing a lot of. Yes?
On the previous example where you had the 3 different processors,
Yeah.
were they all looking at the exact same sequence
Yes.
of messages? But
Yes.
on the one you just put up, I assume that each one's grabbing off a unique message. So that's an option?
That is true, absolutely true. So yes, in this use case here, so let's go back to this point right here. So we've been able to scale out, and each one of them is able to take down messages. And what happens is when a message gets read, Redis marks it as pending. Okay, so now when the next consumer pulls down an image or an entry, it does not pull down the next entry, it pulls down the next entry that's marked not pending, right? So it'll skip the pending ones because those have already been read. Okay, I'll get to that in a minute, but that's how that's handled, okay?
Sorry.
Yeah.
Does it retry?
What's that?
Does it also do the retry if it fails?
Yeah, so I'm going to answer that, but I'm getting ahead of myself. But I'm going to answer that. Okay, so yeah, so what would happen is, well, here. So what happens is you might end up having, you know, one of them go down. I can't remember what that second image there is for. Okay, so what ends up happening is this thing goes down, all right? Or, before I even get to that, yeah, let's just say that this image, this pulls down an image, and something crashes, like it's not able to process that image. And so it can then say, well, I didn't get it, so I'm going to go and pull down that same image again, even though it's pending, I know the ID, and so I'm going to pull it again. Okay, now we can do that. Now, if it crashes and it doesn't remember the ID, now we have a different problem, right? Because what essentially just happened there is this thing just crashed, and so now, I think the X is in the wrong place here, but what happens is it crashed, and now that record, that image was not processed, and the clients now don't have any record of it ever have been pulled. So it's just stuck up there in this pending status, right? So what happens? So what's going to happen? Okay, I'm going to skip ahead here. Let me just pass this up. Okay, so let me catch up here. Okay, so they're all pulling down different images, right? Oh, that's what that was. It was some sort of Disney movie or something. Okay, I can't remember what that was. All right, so they're all pulling down different images, and then as soon as it processes it successfully, let me also mention something else. So if you're going to do it like this, you should create a group, okay, a consumer group. A group has more functionality, and it has this functionality in it, okay? So you create a consumer group, and you're going to add, and then instead of saying xread, which is the normal thing, you're going to xread group. Okay, and you're going to group, pull a value out, and then once you're done processing that entry, you're going to send back an acknowledgement. And now we know that that particular entry is no longer pending, it's been completed. Okay? And you can choose to delete it or not.
So what is added? Whole group is a clash. So decide.
So if the whole group has crashed, then with Redis, many people don't know this, but Redis is persistent. Okay? You probably didn't know that. A lot of people don't know that. So Redis is persistent. All right? So when it restarts, that group will still be there. Okay? Now, you have to configure that. So you got to make sure you, in your config file, or when you start Redis, make sure you say persistent. Okay? Believe it or not, by default it is persistent. But when you're on your laptop, it's storing it on your computer, and you don't really realize that it's storing it on the disk. You probably didn't think about that. But if you are running Redis on your laptop, and you shut down Redis, and then you restart Redis, that data is still there. Okay? What happens is it stores the data on disk, and then when you restart Redis, it pulls that data back in. Okay? Now, by the way, I'm just going to take a moment to explain this because this is very important for you to understand about Redis. Most people completely don't understand this at all. When you pull data, when you ask Redis for data, like a get, it is always going to pull that data out of memory. Always. There's never a time when it says, oh, I don't have that in memory, let me go get that off disk. Never. And you can always rely on Redis to go get it out of memory, and you know it's going to do that. That's one of the reasons it's so fast. If it fails, because the data is actually backed up on disk, you're going to get your data back. Okay? Now, there's one caveat to this, which is probably why Redis gets a bad name sometimes. By default, what happens is Redis only saves the data to disk after it has responded to the client. Okay? That's the trick, that's the gotcha with Redis. So, by default, when you write to Redis, it responds to the client, and then it saves to disk. So there's a very short period of time, about the size of, length of a snap, where if Redis were to go down, there's a chance you lose some data. okay? But if you're using it for a cache, or if you're using it for user sessions, those are, by the way, the two most popular use cases. You're probably okay. Okay, you lost part of your, maybe one key in cache, or maybe one user gets kicked out and you gotta log in again. Okay, not the end of the world. But you want that performance, and that's why Redis defaults to that, because that's where it dominates. Okay. Now, if you want that data to be saved before you respond, that's just an extra attribute in the command. Okay, and then it will save to disk before it responds to you. So if you need that data to not ever be lost, that's all you do. People don't know that, and so they think Redis is all in memory and you're going to lose your data. No, you're not. Okay. When it gets to sharding and all that kind of stuff, now you have to get into more complexity, but again, you're not going to lose your data. Okay, so before I go any further, let me show you some examples of how this works. All right, so there is a Redis stars program that we run. It's like a simple little community. It's kind of a gimmick, actually. But I'm just going to, rather than having to type all these things, I'm just going to come in here and do it manually, or copy and paste. So let's see if I do, okay, now Xlink Twitter stream says I have 26,000 entries in there. Okay, so you can see all the entries adding up, right? But let's do, I'm going to do this one record at a time. Actually, here. Let's just clear this out. All right, so what I'm going to do here is, oh, you can't. Sorry. It gets me every time. All right. Okay, so there's this program up on our website. It's called Redis Stars. You can join it and get some points and all that kind of stuff. It's kind of fun. But what I'm doing here is I'm simply typing in xadd, which is the command you can do all the time. Stations is my stream ID. And then star means I want Redis to create the counter. So basically like the time ID, okay, timestamp. I'm going to have the server do that. And then ID 101, so that'd be like station ID 101. The temperature is 17.7 degrees Celsius, humidity is 58, pressure is 28.84, okay? So adding in some attributes from a weather station, okay? So it got added, and then this is the timestamp that comes out, right? And then that timestamp has a -0. Anybody want to guess as to why there's a -0 there? What's that? Okay. First entry is probably close enough. Okay, it's the first entry within that millisecond. Because Redis is really fast. To write more than once per millisecond, very common. Okay, so if there's more than one entry per millisecond, you're going to have the same exact value here, but it'll increment to 0. All right, that's just a way of making sure they don't duplicate timestamps. Okay, so now let's do a couple of these. I'm just going to copy and paste. It's so much easier than type all this stuff. All right, so we'll copy and paste a few of these. I wrote this little riddle for a riddle in our newsletter every week. Okay, so basically I just added 4 entries from 4 stations. Now I can do xlink stations. And I can see that there's 4 entries. Remember, we had the 4 entries, 70 entries before. So now I just simply have a different, my stream key is called stations, and I have 4 entries in there. Now, what you can do is you can say, all right, I want to do info. Is it streams? Yeah, stream stations. Oh, it's Xinfo, of course, yeah. Okay, sorry, thanks. Okay, so that tells me some information about my stream. It says the length is 4. How is the data being stored? Here's the last generated ID, that's important in case you want to know where you last left off. Here's the first entry, here's the last one. Okay, it's kind of useful to have that information to know how long your stream is and where to begin and stop. Okay? And we already did X length. Okay. Okay, now, if I just want to pull out one entry, I'm going to say X range stations, okay, from the beginning to the end, but only count one. Okay, that just means anywhere in there, but from the beginning. You give me one. Okay, so it's going to give me one, which should be the same one as the one up there. It is. Okay, at the top. All right, so that's how you get out one particular key. I can also specify a specific ID, okay, which should give me the same thing, but I specified the ID there. Okay, I can choose a range of entries. Okay, X range, and then I specify the beginning and the end, and I say, give me, oh.
Time size different.
Yeah, I forgot about this, so I gotta type them in again.
Your first time.
Yeah, let's see here. Let's see. It should be this one, right? Okay, but I only said give me one. That's why it's only one. So anyway, if I said 4, I think that would actually be 4. Yeah, there we go. Okay, so I just pulled out all 4. All right. So you're getting the hang of this, right? I can say now trim. I've got 4 of them, but I want to trim my entries to 3. Okay, so I'm going to trim it to 3. And now, if I take a look again, it's going to tell me I now only have a length of 3. So I just got rid of the oldest one. Okay? All right, you guys getting the hang of this?
Mm-hmm. Yes.
Okay. I can even delete. Now, can you delete in Kafka? No. Okay, so Redis is a little different in that it gives you that ability. I can actually go delete. And now, if I can do info, there's only oh, I forgot. So I deleted based on what was in that page, not. Now if I do that, it's going to say there's 2, right? So in Redis you can delete. Now this can be very useful because what if you're not supposed to be storing data about some of your users? You can delete it before you actually send it off to perhaps Kafka. Okay? So you can clean up things before you actually send them off. So that can be very useful. All right, so now after I've deleted, okay, well anyway, you get the idea. So that's how Redis streams works. Now, I did not get into consumer groups here. Consumer groups are a little bit extra. And I'm going to wrap this up pretty quick here. Okay, here's all the commands for Redis streams, so there's not that many. Okay, you just go to, actually, if you just go to redis.io/commands and then choose streams, you'll see this page. Or you can go to our Redis Labs guide. Okay. Now, again, we just did X add and X read. That's basically what we just did. Okay, you can add and read. You can pull down a range. Okay. And here, once you get into consumer groups, so now with consumer groups, there's a command to create a consumer group because it doesn't just automatically generate consumer groups for you. So you create a consumer group, and then instead of reading xread, you use xread group, and you pass in the name of the consumer group, and you can actually pass in multiple streams. So it'll actually pull down from multiple streams if you need to. Very, very efficient. Okay. So that's how you create a group. and that's how you read a group, okay? And again, you can have 2 streams if you want. I'll pull them both down. Remember, you do the acknowledgement. I told you that. That's how you tell it that I've already read a entry from a group. Okay, and then, by the way, I'm happy to share any of these slides with you guys, so yeah, don't, you don't have to take too many photos. Okay, so you can read from a group. Now, what happens if you think that another consumer has crashed? If another consumer has crashed and it has not, sorry, I forgot the name of the word already. It has not acknowledged, okay? Then what you can do is you can claim unread entries. Okay, so for example, let's say that your consumer crashes and it comes back up and it doesn't remember what it read in the past. You can tell it to then read and get anything that has not been acknowledged. So you can say, I want to claim a key that has not been acknowledged. Now, is this a good idea? What's that?
Doesn't sound like it.
It doesn't sound like it. Now, here's the problem that you have with any stream. With any stream, you can always have read at least once, and you can have read at most once, but it's very, very hard to get read exactly once. Okay, so it's very, very hard to do. All right, so I don't have time to get into how you do that, but I just want you to know that's hard to do. But it can be done within limits. Okay? All right. So by default, you might simply do this, and then what your consumer might do is say, well, have I already consumed this? Okay, something like that. So this is how you would claim those, something that was pending. Maybe you would do is you'd say, give me everything that's been pending for more than 5 minutes or something like that, right? Do you have a question?
You said that an application can read from multiple streams.
Yes.
And so when I get something back, it tells me what stream it came from?
Right.
Okay.
Tell you what stream and what entry, and then the values, yeah. Okay, so that's how you claim, let's see, yeah, X pending, X claim. So I'm going to X claim from a group, a range, anything in that range that's pending, I would like, or I would like to claim. So it's basically taking over as if it read it for the first time. Okay, so I did my demo. And the example I gave you, of course, was Twitter, and you've got a bunch of groups and reads out there. So I think I'm pretty much done. There's a bunch of client libraries, so most likely your client library supports streams. Not every, it's only a year old, not every client library has been updated to support streams, but most of them have, most of the popular ones anyway. In fact, I know somebody just contributed one for closures, so closures now added to that list. And that's it. So I'm going to do a two-part question. Let's go ahead and turn the lights on. Marty, come on, get the lights on. We're going to do questions in 2 parts. First part is specifically around streams. Anybody have any questions around streams? I did that good. You were in the back one first. Yeah.